Alright, hopefully this take is successful. I want to take you all through the first 12 problems on the Calc BC final review in this video. I apologize for my handwriting. I am left-handed, and you're probably not going to see my work while I write. Alright, problem 1, u sub. We're going to set our u as sine of 3x du equals 3 cosine 3x dx. Perfect. Now, since we have a 3 here and effectively a 1 here, we're just going to cancel that out with a 1/3 times the integral of u cubed du. Perfect. So this becomes 1/3 times u to the 4th over 4 plus c, which equals, I'm just going to sub in for u here, sine to the 4th of 3x over 12 plus c. Beautiful. Problem 2. This is another very easy u sub. We're going to set u as equal to square root of x, which is x to the 1/2. So then du is equal to 1/2 x to the negative 1/2 dx. And since we have a 1/2 here, no 1/2 there, just a 1, we cancel that out with a big old 2. All right, 2 times the integral of 10 to the u du. Now, if you haven't taken the integral of an exponent with base other than base other than e, how you're going to do it, the integral of b to the x equals b to the x over L and b. It's that easy. So we've got 10 times, 2 times 10 to the u. I'm just going to sub in for u immediately over ln 10 plus c. That's your final answer. That's all you got to do there. All right, problem 3. Problem 3, we are supposed to use the limit and then use a variable instead of infinity. So I'm just going to go ahead and integrate right away here. Since we have 3x to the negative 2, that just integrates to negative 3x to the negative 1. And we are continuing along with b here. And negative 3 over b minus negative 3 over 1. Negative 3 over infinity in this case is 0. So this becomes negative 3 over 1, which is positive 3. Problem 4. All right, this is a partial fraction decomposition. So I have a over x plus 1 plus b over x plus 2 equals 4x plus 7 over x plus 1 x plus 2. Hopefully you're comfortable with setting that up. Now you're going to multiply by this denominator. So a times x plus 2 plus b times x plus 1 equals 4x plus 7. Now we're going to start getting some of our a and b constants here by setting their coefficients as 0. I'll start with a. So if x equals negative 2, then we have negative 1b equals negative 2 times 4 is negative 8 plus 7 is negative 1. b is 1. If we set x is equal to negative 1, b is going to cancel out. We have positive 1a equals 4 times negative 1 is negative 4 plus 7 is positive 3. All right, so now we have a and b. We're going to plug in here and integrate. So integral of 3 over x plus 1 over x plus 2 dx equals 3 natural log of x plus 1 plus natural log x plus 2 plus c. Perfect. That is our final answer. Problem 5. You have bounds mini 42 with your friend. Problem 6. This is another integrate by parts. If I can get the problem out here. Perfect. Whenever you see a natural log in your integral, automatically that's your that's your u rather, and then you're going to just do one step. Don't forget your dx, and you're done. Now, on your dv side, we really just have 1 dx, which integrates to x. So we're going to take that product minus the integral of that product right there. So that is x ln of x plus 2 minus the integral of x over x plus 2 dx. Now this is a u sub. U equals x plus 2, du equals dx. Now, you may be wondering, what's the use of this x? This x isn't subbed in as u anywhere. U equals x plus 2, x equals u minus 2. Oh. You've just subtracted 2 from both sides over here. So I'm going to work on this down here. We really have the integral of u minus 2 over u du. So we're going to separate that in 2. I'll make this bigger so you guys can see. U over u is 1. 1 minus 2u to the negative 1 du, which integrates to u minus 2 ln u plus c, and then we're just going to plug in our our u rather. We're going to get our x's here. X plus 2 minus 2 ln x plus 2 plus c. Now, since we have a 2 here, that's just a constant. That's absorbed by our c. Now, what we have left, we're going to plug in right there. So I'm going to be swapping the signs because it's negative. So our final answer is x ln x plus 2 minus x plus 2 ln x plus 2 plus c. On to problem 7. Perfect. All right, now problem 7, the first thing I'm going to do here is I'm going to factor out a 4. 4 times the integral of x cosine 2x dx. This is another integration by parts. Our x would terminate pretty quickly if we start taking derivatives, so I'm just going to do one step there. X, derivative of x is dx. So we start off, dv is cosine of 2x, and taking the integral of that should give you the sine of 2x over 2. That product minus that integral. So we have x sine 2x over 2 minus the integral of sine 2x over 2 dx. That is very easy trig. We just get, oh, and I'm going to bring in our 4 here. So we have 4 times the entire product, x sine 2x over 2, plus rather, because this is going to be minus negative cosine, plus cosine 2x over 4. Because chain rule of that 2x, we would divide that by 2, and we already have a 2 in our denominator, so that just becomes 4 plus c. So one more time, that's going to be 2x sine 2x plus cosine 2x plus c. All right, finally, problem 8. Very easy u sub. Once again, u is x squared plus 9, du equals 2x dx. And since we have a 2x in our problem, that's perfect. We don't need any coefficients to cancel out there. We just have the integral of u to the negative 1 du, which becomes natural log of u plus c. Plug in for u, natural log x squared plus 9 plus c. All right, let's do some compounding interest problems. Starting with problem 9. How much interest will $1,000 earn at 4% for 3 years? So 1,000 is going to be our P, 4% is our R, and 3 is our T. So let's plug this in. However, you need to notice how much interest will be earned. This isn't the ending value. This is, since it's earning, this is going to be our change. So we're going to subtract our initial value of $1,000. So if I can pull out my work for reference here, we're going to have 1,000 e to the 0.04 t, which is 3 minus our initial value of 1,000. Plug that into any calculator, graphing, scientific, whatever have you, and you should get 127.50. Problem 10. Find the present value of a bond that matures in 5 years at 6% for $3,000. So, looks like our y is going to be 3,000 because that is our end result, present value. I'll call that x, but that's pretty much your p or your a. And then 5 years is your t, and 6% is your r. So let's build our equation here. 3,000 equals p, which is x, e, to the 0.06 times 5. Perfect. So we are going to divide 3,000 by e to the 0.06 times 5. Again, any calculator will do. And you should see that x is equal to $2,222.45. Problem 11. How long will it take a sum of money to double at 4%? Basically, since e to the RT is the factor of multiplication for your base value, you just want e to the RT to be 2, if that makes any sense. 2 equals e to the RT. So you're looking for t, and you have r. So 2 equals e to the 0.04t. So we are going to take the natural log of both sides, which is going to cancel out the e. So natural log of 2, and then we're going to divide by 0.04. And that should give us our answer in years. 17.329 years to be exact. Finally, problem 12. Find the half-life of a radioactive element if it takes 3 years for 20% to decay. Okay, if 20% has decayed, then our end result in this equation is 0.8, 80%. Equals, our starting is 1 in this instance, so we don't need to worry about notating anything there. E to the t is 3 in this case, and we are looking to find r first. We don't know r right now, so if we find r, then we can plug that in and find 0.5 instead of 0.8. So to find r, we want the natural log of 0.8 over 3, which should give us negative 0.074. Perfect. All right, the next step, now that we have r, is let's build our equation. So y, our desired value, our ratio of our percent left is 0.5 equals 1 e to the 3 times negative point. Oh, sorry. We don't know our t this time. So instead of plugging in 3, we have our negative 0.074t. So to isolate our t here, we're going to take the natural log of 0.5 and divide it by negative 0.074. And your final answer should be roughly 9.3 years.